Hello, everyone, and welcome to this webinar, HQA Connect for PolyWorks, brought to you by CairnHill and HQA. I am Lisa Sterling, your host and moderator for today's session. But before we get started, I would like to mention just a couple of housekeeping items. On this next slide, we invite you to ask questions throughout the presentation by typing into your Q&A tab, which you will find at the bottom of your screen, as your phone is muted during the session. We will address the questions received at the end of the presentation. Please note that this webinar is being recorded and will be available for playback in just a few days. I would now like to introduce you to our presenters for today. Shi Yu, Regional Applications and Measurement Manager with CairnHill. Josh Olmsted, Director of Product Enablement with HQA. And Chad Helland, VP of Strategic Accounts, also with HQA. And let's take a quick look at the agenda for today. In this next 45 minutes or so, first we will give you a little bit of a background on CairnHill metrology, as well as HQA. We will then talk a little bit about the HQA Connect for PolyWorks product, and then even show you a product demonstration. We will finalize with a Q&A session where, again, we invite you to ask questions just by typing into your Q&A tab at the bottom of your screen. And at this time, I would like to turn the floor over to Shi Yu to get started.
Hi, good morning, everyone. Thank you for joining us today. Okay, my name is Shi Yu. I'm a Regional Application and Measurement Manager at CairnHill Metrology. Today, I'm excited to introduce our webinar on HQA Connect to PolyWorks, where you will explore how this solution can streamline your measurement process. So I would like to begin with a quick introduction about our company, CairnHill Metrology. Next slide, please. So we established on 1983, and over the past 4 decades, we have grown to become one of the region trusted provider of industry metrology solutions. So we work closely with leading global technology principles, and we complement their innovations with our strong commitment to service and support. Today, we operate across Singapore, Malaysia, Indonesia, the Philippines, and Thailand to deliver the uniform high standard of metrology solution throughout the regions. Our vision is to be trusted metrology solution provider of choice, and our mission is to help customers achieve process efficiency, improve yields, and consistent quality. Okay, next, please. So at CairnHill Metrology, our strength lies in offering a complete portfolio of solutions that meet a wide range of industrial requirements. For the food and pharmaceutical industry, we provide inline automated check weigher, X-ray system, and metal detector to ensure product safety and compliance. In the industrial metrology, we offer CMM, surface roughness tester, contours and roundness machines, gear tester, and profile projectors. For portable metrology, we supply portable arm CMM, laser and optical tracker, 3D digitizer, scanner, and gauges. So this to providing mobility and flexibility for the on-site measurements. And finally, we complement this hardware solution with a suite of software solutions for visualizations, analysis, metrology, process control, and reverse engineering. Together, these solutions form a complete ecosystem that support our customers' manufacturing and quality needs. Next. So beyond the solutions, CairnHill is strongly committed to delivering reliable services that maximize the value of our customers' investment. So under application and measurement service, we provide accredited CMM measurements, XCT dimensioning and GD&T, surface finishing and profiling, reverse engineering, and training. And under technical services, we provide pre- and post-sale support systems, commissioning and training, preventive maintenance, troubleshooting, repair, and also calibrations. We also offer service contract, retrofit, upgrade, as well as rental and pre-owned equipment options. All these ensure that our customer not only receive advanced technology, but also the expertise and life cycle support to achieve consistent results. Okay, to sum up, CairnHill Metrology is here to support manufacturers across the regions with a combination of technology, services, and decades of expertise. We are very proud to partner with HQA today, a global leader in quality management software. Today, we will share with you how their solution can further enhance productivity, streamline quality process, and strengthen compliance in modern manufacturing. With that, it's my pleasure to hand over to Josh from HQA, who will now take us through today's main webinar topic. Josh, the floor is yours.
Thank you, Shiyu. Appreciate the
Thank
time.
you.
For those who don't know, my name is Josh Homestead. I'm the director of product enablement here at HiQA. I give you guys a little background of who HiQA is. HiQA is a manufacturing quality software company, and our mission really is to make quality easier for everyone. Our goal is to streamline and automate the entire quality process from the moment a part is defined all the way through final reporting and delivery. So we're proud to be the trusted partners for many manufacturers and OEMs globally across industries like aerospace, defense, automotive, and more. And we work closely with our customers to help solve their most complex quality challenges. And above all, we really focus on empowering our teams to collaborate more effectively, both within your operations and across your supply chains. And on the next slide, you'll see this is HQA 360 is our manufacturing quality platform, and you can see that we touch really 4 different areas across the quality lifecycle. So first, we're really involved in our quality planning. So it starts with the dissection of 2D auto ballooning or 3D injection of a model, creating inspection plans and sampling plans out of that model. The inspection plans themselves, so importing actual results, real-time SPC, and CRs and tool engage management, and then ultimately the reporting output of that as well. So maybe that could be a first article inspection or a lot report. Maybe these are full PPAP submission documents all the way through material and process certs, and it brings it through a full digital workflow with traceability throughout that process. And finally, through our 360 Hub platform, which we're not going to show today, we also bring supplier collaboration through this as well. So being able to take those same 2D and 3D models, collaborate with your suppliers, and exchange those same documents that we're talking about in real time with supplier audits and scorecarding as well. So if any of those sound interesting, you can talk to us after the fact, but we're going to really focus today on our implementation with PolyWorks connector. In the next slide, I think we're actually showing some of the global strategic accounts that we've worked with. So these could be OEMs, again, across many different various industries, and then all the way down through could be tier 1, 2, 3 supply chain down, even down to mom and pop machine shops that have found value out of implementing HiQA software solutions. So the next slide we're going to show is really why HiQA and InnovMetric, who is the parent company to PolyWorks, why we joined forces. And really, the bottom line is we share a lot of values between our products. We both have a deep understanding of manufacturing and where that meets quality challenges. And we both believe that our tools, our software works better together than it does alone. And finally, the goal of this is to unify a digital thread, so having the same source of truth starting in manufacturing engineering, bringing it all the way through QC, metrology, and back again with standardized workflows. So without further ado, let's take a look at our HQA Connect for PolyWorks platform, with really the goal of this particular integration being to accelerate 2D to 3D measurement planning. So let's take a look at what that looks like. So the challenge here that we're often running into is the conversion of 2D drawings into a 3D metrology software like PolyWorks. So many of you may be familiar with PolyWorks, but if you don't know, they position themselves as a universal metrology platform. So you can use their software, and they're hardware agnostic. So you can use that same software and workflows across many different metrology tools at the end. And they use a 3D interface in order to program those tools. So it's low code or no code in many scenarios where you're either typing or dragging and dropping across the actual 3D model. So this is great. It brings a lot of benefits by using that program, but the challenge becomes when you're taking something like a 2D drawing and trying to bring that into that 3D environment. Typically, the metrology expert is actually working from a completely unballooned drawing or sheet. They're having to interpret the GD&T that they see on that sheet. It's time consuming. There's a lot of typing and risk of typos or mismatches across that process. And ultimately, a quality engineer is likely already interpreting that GD&T for use for other inspection planning processes or throughout their quality lifecycle. So it's really redundant to work that is already happening on the shop floor by other team members. And so it's really a disconnect because they're interpreting that same blank drawing twice, ultimately leading to different versions of the truth and increasing the risk across the process. So on the next slide, we show really the solution that we're bringing to this, and we'll show you how in just a second with a demonstration of the product. But the idea is that HQA Connect for PolyWorks really cuts through all of those challenges. It accelerates your 2D drawing to 3D measurement planning and dramatically cuts through programming time. We're seeing anywhere from 3 to 5 times increase in measurement planning, and that's on top of the efficiencies that our customers had already received by using a platform like PolyWorks. We're seeing huge increases in accuracy and reduction of errors because it's a database to database driven product. There's no typos or and if there's mismatches even between a drawing and the 3D model, it will automatically flag that. We'll see that in the demo coming up. And then finally, because we're keeping this chain where a quality engineer is defining this source of truth ahead of time, it's unifying and aligning your teams and your data from the start with the measurement planning portion and extraction of GD&T, but also in the end, when a programmer from a CMM or other metrology tools is bringing the operational data back into HiQA for reporting or additional analytics through data loop PolyWorks as well. On the next slide, we're basically going to bring you through a demo now of what that looks like. And just as a quick disclaimer, we just want to let you know that this is what we're going to show you is a full end-to-end solution. So it's utilizing the full range of our product and integration, but you may not have all of those pieces in place currently. So maybe you're only using HiQA partially, or maybe you're not using PolyWorks in a production mode. Maybe you're only using it on some of your machines or in a prototyping phase. Maybe you don't use data loop currently. All of those things are okay. The software and integration is built to be flexible to your environment and your implementation. So you can start getting the benefits of the integration immediately while still having room to grow into the full promise of the integration. So with that, I'm going to turn over. This is a pre-recorded video of Chad at HiQA, who's going to bring you through the demo of the system. Go ahead.
We're going to start with something familiar. On the right, you'll see a model in PolyWorks Inspector. On the left, you see a 2D drawing. This drawing could be a PDF, it could be an image, or it could be a scan, but in either case, there is no metadata in here. Typically, a CMM programmer has to look at this, interpret the GD&T they see, and transfer that over to the model on the right. We're going to focus specifically on this characteristic. We can see there's a diameter and a specifically called out tolerance, but there is no balloon numbers yet. To accomplish this, we'd select the circle tool over here, select our feature, and then evaluate the information that we see down here. Now our nominal is close, but we're going to make a small adjustment so it matches exactly. And then our tolerance has to be completely changed. Once that's complete, we'll verify our control matches. And if we had a balloon number, we would change that or enter that right here in this characteristic number field. Now, this is a relatively simple drawing with not a lot of characteristics on it, but imagine a scenario where we have 500 on here, which is a typical use case. There's three big problems with this. Number one, it's very data intensive. Number two, it's very easy to make an error, and not only that, but not catch it, so it would get out somewhere. But number three, it's also duplicated effort. This is typically already being performed by a quality engineer or a manufacturing engineer. Somebody's already done this work, and now we're repeating that. But what if there's a better way? Well, now there is, with HQA Connect for PolyWorks. So let's show that process. First things first, I'm going to remove my circle, and we'll minimize this. So now on the left, you see PolyWorks export inside of HQA Connect. To start this, we're just going to click on the feature. You can see we have an export button and a cancel, but as soon as I've clicked on that, it is now giving me step-by-step instructions on the model side of what I need to do to perform this. So I need to select a circular feature and then click export. Let's grab our circle tool, select our feature, and click export. As soon as we do that, it is now pushing that information over. Everything looks correct, and it's told us that it's complete by changing to green. All that data that got pushed over already resides inside HiQA and is being digitally transferred over. Now we'll just continue that process for the rest of this. Click on our second characteristic. We need to select our slot tool, grab our feature, and click export. Again, that's populating our information, and it's good. Next, we have this plane to the center of our hole. We already have our hole, so we'll just grab our plane tool, select that, and now we can select those two at the same time. Click export. As you can see, I didn't have to do that in order. I got a little bit ahead of myself, but it understands either way if I didn't need those instructions. In this case, I'll go with them the correct order. Very similar scenario, just a different plane to our circle. So I need my linear feature or two features to create that distance, which happen to be our circle and our plane. So I will make this plane quick, which happens to be plane 3. Make sure I have that selected again, as well as my circle, and export. There it is, and we're green. Last on this one, we have an angle feature. That happens to be right here with these two planes. So I'm just going to grab that, click, click, make sure I have both those selected. Export, there it is. If I click on this, I can see that information as well. That's page 1. Let's continue on to page 2 now. Now, when we get to this page, we can see there's some darker boxes. That signifies to me that I have some datums that I need to address. Okay, so we're going to go back to centering this model here. And we're going to start by clicking on this box. And now we can see the first thing it's asking for is exporting datum A, which is what it says here. So I need to identify which one is A, which happens to be my slot feature here, the surface of that. So this is plane 3. I select that, export datum A. Next, I need to export for datum B, which happens to be my big hole feature here. So I'll select this plane here. Not that one, not that one. It's not that one. I don't have that one picked yet, so let's make that. create our plane, export. Last, we need to do C, which is this bottom plane. We've got it identified as plane 2. I'll grab that, export. There we go. Now all of our planes are identified. So now we're going to actually identify this pattern. You can see those darker boxes are gone now. So now I need to identify my different hole patterns here. So I can take my circular tool, select my first of 4, second, third, fourth. And if I wanted to, I could make a pattern first, but I don't need to. So I'm just going to hold down Control and click my 4 circles and click Export. All of this data now is getting pushed over for these holes. You can see it happening in real time over here. There's my first of 4. Now we're on to our second of 4. And again, all of this typically would have been hand populated in the past. It's turned green. We are now complete. But another thing it's done as well is if I expand this pattern, we can see some stuff. Number 1, this is 3 distinct characteristics that need to be checked. So we have 6.1, 6.2, and 6.3. But to take it a step further, we have it 4 times. So if I click on circle 7, you can see there's another delimiter on there that identifies which version of which. This is the first one, the second one, third, and fourth. Okay. Continuing on, we'll go to our number 7. Now in this case, all I need is datum A. So I'm just going to select datum A, export. 8th, I have a hole here that I have not built in yet. So I need to select my circular feature, which I have not identified yet. So I'll just grab my circle tool, grab it, and export. Oops. Here's another thing that we're doing while we're populating this information. We're doing an evaluation. This is looking for an expected 18 with no decimals on our millimeters. What we actually see is 18.0432, which is outside of our allowable delta. So this is validating that information the same time it's pushing that over and populating that. We can see that down here as well. Now, if I cancel this, it will stick with the 18.043 and we will not be pushing any information. In this case, I'm going to override that. So it's going to push that information over there. Turn green. You can see our values are correct now. We'll continue on. Once again, this one happens to be just to a datum. So I can select my datum C and export. Green, we're complete. Last, once again, we just have a datum, so we can select our datum B and export. And just like that, we're done. That's the whole process from start to finish on this. Now, obviously, this is a lot of time savings on this smaller part, but that just grows with the amount of complexity. So next, we're going to go into showing what this looks like, how that data was actually generated inside HQA. This is HQA's Inspection Manager. We can see that a quality engineer or a manufacturing engineer has already performed the ballooning process on this. We can also see down here the bill of characteristics that were generated from that. We have the requirements, the nominals, upper and lower tolerances, sampling rules. We even have those shown in alternate unit sets, in this case if they wanted to use inches instead. All of that resides inside the database. This is also the same exact part and job that we just used to push the data over to the PolyWorks model. Now let's see how we actually generated that. I'm going to click on New and bring in my drawing. Once that's in here, I'm just going to click on Auto Balloon. And I'm going to change it to ballooning all pages so that I'm doing more than one because I have 2 pages here. Once I click OK, this is going to identify the outside border of this as well as the box for the title block, so I'm not working inside that. Then it's going to go top to bottom, left to right, ballooning all of the characteristics, putting boxes around those, and okay, and we're done. And populating the bill of characteristics down here in the bottom. Looking at our first one here, this should match what we see up here in the preview box. I can see my nominal, I can see my tolerancing, I can also see what my default tool that I've assigned for. All of that information resides inside here, and my next step is to make sure I review it. Once I've done that, that does two things. That takes me on to the next characteristic. It also marks this as reviewed. So if I get pulled away to do something in the meantime, I know where to come back to and where I need to complete so I can finish this process accurately and trustworthy. Same thing with this. I would continue on through the rest of these. Go on to my next page, validate this. Now we can see something here that didn't get caught. This isn't a perfect system, but we do have tools in there to make sure that we don't miss anything, whether it's a nice clean drawing or it's a hand-drawn drawing that was drafted in the 60s. So in this case, an easier way to see this would be to use this whiteout balloons button. Now imagine that we're looking at that 500 characteristic example again. This is going to be a lot busier than it is here, but turning this on hides all the balloons, which makes it a lot easier to see if I did miss something. So now I can just use my manual tool, draw a box around it. It'll read that, and there we are. We're good. Continue on as we normally would. Now I can turn that back off. Now, one other thing you'll notice is because we did that, that is no longer in numerical sequence. So the last thing we would do once we validated everything in here is just click on renumber. And now they're all in sequence for us. One other note that I want to show is the ability to capture the materials. From here, I can just click on my blue material button, select that, and that now becomes a new entry in the system. I can be populating other pieces of information in here, but more importantly, I can upload certifications and such that flow through this when it comes time to do any kind of document submission packets, CFC, etc. So now that we've accomplished that, let's look at bringing data back in. To do that, let's go back to the job we used to propagate PolyWorks. With this open, we also need something to inspect against. So let's go to our samples. I'll create 3 of them called HQA 1, 2, and 3. Now that we have these, let's go back to HQA Connect and PolyWorks Inspector to bring in some results. Before bringing in results, we should make sure that we have the information needed populated against our project. To do that, we simply click this Properties button, which will populate that information into here, again from HQA. Additionally, this is setting this up as a piece template, which allows us to perform the next step, which is creating our samples to be inspected against. So with that, we can now click on Create Pieces. This will populate the samples into here that we just created in HQA. I'm going to select the first one for us to populate against. Now we have that. The last step we need to do in this case is set up a virtual device because I do not have a CMM available to me at the moment. So we'll turn on offline simulation and we'll scan our part. All right, now that we've concluded the scanning, let's look at our results. For those of you who have Data Loop, we have a built-in integration that syncs the data between both of our databases. This allows you to leverage the tools that both are strongest in. We can break this into SPC data. We can look at heat maps. That is a simultaneous sync that shows the results in both systems. So you can dissect your models in PolyWorks Inspector and in Data Loop, and evaluate the results inside Inspection Manager. We do also have other ways of bringing the data in. It can also come back in directly from the CMM. From inside here, we can also add non-conformance records for failures if need be. associating those to defect codes and operations for full traceability. The last piece that I want to show inside here is the reporting aspect. We have a PQP area for full submission packets. This may be any kind of documentation that you need per your customer's requirements, from balloon drawings to part submission warrants to PPAPs, process flows, control plans, FMEAs, gauge R&R, material certs, etc. And these can be customized as needed. We're going to focus specifically on the first article here. Inside each of these, we also have what we call workflows. This allows this to be controlled and making sure that your I's are dotted, your T's are crossed. The correct people are associated to tasks, and those can't move on unless they are completed. This also drives notifications in the system, as well as emails, to ensure that those are timely. Back on our document, this is what we call our interactive forms. Anything on here that's yellow, I can type in. The check boxes I can check. And then down here, these have full digital signatures tied into them. Then below that, we have the information that came in from our results. All of this finishing out the process to submit a quality product to our customers. Thank you for your time.
Awesome. And thank you, Chad, again, from wherever you are for creating that. That was a great demonstration. Really what this brought you through, and I'm just going to highlight some of the key benefits out of the demonstration that you just saw. Really, one of the main messages that we're seeing is dramatic time savings across this entire process, and it's in a few different areas. So first of all, we're seeing the measurement planning is anywhere from 3 to 5 times faster with our connector than it is typically manually by hand going from an unballooned drawing into PolyWorks. And that 3 to 5 times faster is already on top of the value and increases that you were seeing by implementing a universal metrology solution like PolyWorks. Also, obviously, from the ballooning side, if you're looking at going from maybe hand ballooning or using a tool like Adobe to balloon your prints, being able to one-click automatically balloon a 2D drawing, people see anywhere from 70% faster across that ballooning and inspection planning process. And I'm not sure if it was mentioned in that demo, but for those that didn't catch it, this wasn't a special PDF. There was no metadata attached to it. It wasn't, kind of scannable or readable. That was entirely an image-based PDF that we imported there. So it could just be a JPEG or a PNG or any other image-based file that you're extracting the GD&T data from. So it's using optical character recognition to read all of that and pull it in. So it's a huge time savings, even across maybe older prints or what we call scan level prints, maybe back from the 60s, like Chad mentioned, where it was a hand-drawn drawing. You can still use this tool. And ultimately, one of the ones that you saw for the dimensions that was pulled over, it was a 4x multiplier with 3 different characteristics on there. It's not uncommon to have dimensions like that, 500 dimensions like that across a large sheet if you're looking in aerospace or defense or automotive industry. So we're looking at something like a 20 hours saved per part just in that planning process, which is a huge time savings. Ultimately, we saw a couple things on how it was improving quality as well. Chad showed you on one of those dimensions, there was a mismatch actually between what the print said and what the 3D model had. There was a slight difference in the delta for the tolerancing. And maybe it happened to be a slight one in this instance, but maybe there could be an error where the 2D print itself was mistyped, or maybe there was an error in the 3D model, or it could have been that a CMM programmer, when they're programming it, they misclicked the wrong dimension. And so there's the built-in warnings there, and mismatch detection is a huge, not just quality of life savings, but a huge quality savings for you as well. To make sure that you're having fewer corrections, less rework in the process down the line, and having higher confidence in your results. And finally, the idea is that this is bringing one universal set of truth for you, from design from that one balloon drawing that's being reviewed and checked by your engineers, all the way down through your metrology that's then able to utilize that same database of results. And then even towards the end, we saw a demonstration where a CMM operator or a metrology operator, maybe it's a laser scanner, is using that plan that the programmer made to get results back in and having an automatic sync between PolyWorks data loop and HQA, obviously creating huge consistencies in workflow and in your training of your personnel as well, since we're agnostic to the file type that's coming in, could be 2D, 3D, and ultimately the machine that you're checking that on. All of the results come back in for a unified reporting experience to your customers at the end. On the next slide, I think, yeah, we're going to open up to Q&A. So if you had any questions that come in, I think there may have been one I see here. Lisa, you can help me go through these.
Absolutely. Thank you so much, Josh, and also to Shiyu. Okay, so let's get started. We did have a question come in. It says, what is the efficiency level of auto ballooning for older drawings or hand-drawn sketches?
Yeah, that's a great question. So obviously it's using a tool called OCR, optical character recognition. And the way it's doing that is it's trying to find patterns within the characters of, hey, this is what an A looks like. This is what a B looks like. This is what a C looks like. And it uses that to detect patterns. So for older drawings, maybe if there were scans of scans, it does fairly well. For hand-drawn sketches, you can still use the software. So as Chad showed, maybe it's not picking it up perfectly through the optical character recognition, but you can still manually draw over each of them. And then if you need to correct, if the character recognition didn't do a perfect job, you have the full tools in there to correct the tolerance or the type if it came in incorrectly so that it's matching it perfectly. And really, it's always going to be a bit of a pain to work with older drawings like that, but the benefit is once that you've done that once in your system, it's now in a database format and you can utilize that across the rest of your inspection planning. So it's just a one-time job. And honestly, when you're looking at that from the HQA Connect for PolyWorks integration, it's even better because you can imagine a scenario where a quality engineer is having to manually interpret this drawing with difficulty, and then also your metrology expert having to do the exact same thing. So being able to narrow that down to a single process for interpretation for those older drawings, you're seeing a huge level of efficiency down to your metrology. But yeah, that's absolutely a great question. Thank you.
Great, thank you. So on the next slide, we actually have a couple of questions that are very common. And the first being, what if we only use PolyWorks for prototyping, not production?
Yeah, and it'll be a bit redundant here. I won't read it out perfectly here, but the idea is that it doesn't really matter. Maybe you're only even using it for just a small subset of your machines. The idea is that you're still going to see that 3 to 5 times faster measurement planning for all of those machines. So in fewer errors, and even in just a prototyping workflow or where you're only using a few of your machines in there. So you don't need full-scale production to get those same levels of time savings or accuracy improvements. And actually, many of our customers are saying because of the benefits that they're seeing with this plugin, they're actually exploring, hey, what other metrology tools do we have in our lab or in production that we can start programming it with PolyWorks instead of whatever software that they were using. And that way they're increasing their benefits across that as well. I'm seeing some more live questions come in here as well,
Yes.
Lisa, so maybe we can jump to that.
Sure thing. Okay, so the next one says, can you explain how HQA Connect manages real-time data synchronization between PolyWorks Inspector and enterprise databases, and what protocols or data formats are supported to ensure system interoperability?
That's a really great question. Yeah, so I'm not the tech behind this, but I'll do my best to explain the technology. The idea is that it's a database to database sync. So it's actually using the API of both PolyWorks Data Loop and HiQA Inspection Manager to in real time sync across the databases. So I know you're saying in here PolyWorks Inspector. Inspector by itself don't believe has a database out of that. I believe you're just creating one-off files from Inspector. We can still import that into HiQA, even automatically through our automatic machine data import tools. So that's okay. But if you have your PolyWorks data loop, which is the database level integration for PolyWorks, it is a seamless database to database transfer. You're not messing with file types or data formats. It's a live sync between the databases using API. So it's 100% interoperable. And because of the way that we're pushing the data from HiQA into PolyWorks Inspector, it has all of the metadata and information needed in order to make a perfect one-to-one match when it's coming back into HiQA for reporting, or whatever you want to use HiQA for, maybe creating an NCR out of a failed result that you captured through Inspector and Data Loop.
Sure. Okay. So here's a question about how the data security works. If you want to talk a little bit about security, even in general.
Yeah, sure. So both products are, I believe, I can't speak entirely for Data Loop on their end, but from HiQA side, we are using a on-premises installation. So it's fully compliant within your IT. So typically you have a server PC that hosts the database and you have clients that connect to that one database. Or if you're in a small, what we call our job shop package, it could just be that that database is installed on that one local install of the computer. And the data is fully secured, encrypted end to end in that. I'm probably not the best person to talk about the full coverage on that, but I know we work a lot in aerospace and defense, which have very high standards in the US. For instance, CMMC in the United States for Department of Defense or Department of War contracts that we actively work with our customers with, and they pass. So if you want more specifics about how we handle data security in Inspection Manager, feel free to reach out to our team, and we can get you an expert in that field that would talk about that. But from our end, the database is fully secured. And on PolyWorks, I know they have as well a local installation version that you can do in there, or I think their data loop also has a secure cloud connection as well, but I can't speak 100% to how they handle security around that.
Okay, great. Okay, so here's a question about subscription. It says how the subscription package, or is this a subscription package? I know we're not going to talk about pricing specifically in this session. We're happy to reach out to you following this webinar, of course. But if you want to explain a little bit about how that might work.
Yep, perfect. And yeah, this would be a better question for a sales team, but it is a subscription-based package. So you pay on a yearly annual subscription. And so the idea would be you need a kind of the minimum package buy-in would be a Inspection Manager Job Shop license, which is our entry-level Inspection Manager license, as well as then a subscription to the plugin itself. And obviously you need PolyWorks as well to make that work. So whatever your PolyWorks subscription looks like, or maintenance looks like on that. But yes, from HiQA's side, it is a subscription-based product.
Okay, thank you. So here's another question about connectors. It says, will HQA Connect support other systems such as PCDMIS from Hexacon or Zenith from Creon in the future? Just as examples.
Yeah, I can't speak specifically to future partnerships in that way. I would say that this is a very unique partnership that we have with InnovMetric. We are not actively seeking that with other platform systems, but we really share, like we shared in the beginning, we share a lot of the same values in InnovMetric and HiQA, especially around the idea of interoperability and being hardware and file type agnostic. We really like the idea of having one universal set of tools that can bring you all the way through your part planning, through your inspecting, and back for your reporting to your end customer. So We do have support for ingesting files from other systems, but this level of direct product connection where we're pushing GD&T into the software like PolyWorks is probably going to be very unique, at least for the near-term future. So,
Yes, makes sense. Okay, so that's it that has come in for the live questions thus far. Again, we welcome questions, or even after the session, if something comes to mind, feel free to reach out to us at any point. We're happy to help. Josh, would you like to touch on the last two questions on screen here? And then we
Sure,
can
yeah,
move
and
on?
I'm sure you're people who are still here, you've had time to read the slides, but the idea is no, you don't need pay to loop to get started. You can get the full advantage of the programming aspect right away, and then down the line, if you want to introduce something like data loop, then you can unlock the full potential of the database to database sync. But yeah, not needed initially to get started. And then this is kind of incidental. How much faster could this really be? And we've talked about this already. One example that is a time study that we did across a 500 dimension piece part, where programming in PolyWorks alone took about 30 hours to do. It's a complicated process to program. And with this plugin, that was reduced to under 10 hours with HQA Connect. So obviously your experience is going to vary depending on how large the amount of parts that you have and how many dimensions you have across your parts, but it's a huge scale of efficiency, even for experienced PolyWorks users.
Excellent. Well, thank you so much, Josh, and also to Shiyu and to the audience for spending this time with us. We really appreciate it. We hope you found it very valuable. We will be sharing this recording with you all in the next couple of days if you'd like to watch the playback or share it with your colleagues. And again, as I mentioned, if any questions come to mind, feel free to reach out. We are happy to help and here to assist. Thanks everyone so much. We will let you get back to your day. Have a wonderful day.
Thank you so much, everyone.
Thank you.